This question illustrates calculating pH at equivalence point. Question says, calculate the pH at equivalence point when 40 ml of 0.1 m NH3 is titrated with 0.1 m HCl. So we have a weak base and a strong acid. So this is a titration of weak base plus a strong acid. Now we have 40 ml 0.1 m NH3. So weak base is 40 ml 0.1 m, and this acid is 0.1 m. Volume is not given for the acid. What we will have a reaction of NH3, that is weak base, a strong acid is HCl. So you see we will have a reaction of NH3 plus HCl, it will form NH4Cl. So from this reaction it is clear that mole of NH3 is equals to mole of HCl, because 1 mole of NH3 reacts with 1 mole of HCl. So we can say mole of NH3, this is equals to mole of HCl. Now mole of NH3 we can calculate by multiplying molarity into volume. Molarity is 0.1 and volume is 40, and this side mole of HCl we can calculate by multiplying molarity into volume. So molarity is 0.1. Let us say volume of HCl is V. So from here we can calculate volume is 40 ml. So volume of HCl required for this titration and this is equals to 40 ml. So in this case we have 40 ml of HCl and 40 ml of NH3, that is both have 4 millimole. So we have a reaction of NH3 plus HCl, this will give NH4Cl. 40 into 0.1, that is 4 millimole. So I will have 4 millimole of ammonia, it will react with 4 millimole of a strong acid, and it will finally give 4 millimole of NH4Cl. Now NH4 plus is basically salt of weak base. Weak base is NH3, salt of weak base. Now salt of weak base will hydrolyze the water, so we will have a hydrolysis reaction. So you have to remember that is salt of weak base hydrolyzes the water. Let us calculate concentration of NH4 plus, that is mole by volume. Molarity, mole of NH4 plus is 4 millimole and volume we have 40 ml plus 40 ml, that is total solution volume is 80 ml. Milli goes, so we will have 4 by 80. Mole per liter is molarity. So molarity is basically 4 by 80, that is 1 by 20. So 1 by 20 we will have, this is 0.05. Now this NH4 plus will hydrolyze the water, so we will have a reaction of hydrolysis. It will hydrolyze the water, so it will have NH4OH plus H plus. Now equilibrium constant, that is hydrolysis constant for this reaction, will be Kw by Kb. Now you see the solution at equivalence point will be acidic in nature because of this hydrolysis. Because of this H plus, solution at neutral point will be acidic in nature. So initially we have 0.05 m of NH4 plus, that is T is equals to 0, and equilibrium time we will have 0.05 minus X, and here we will have X mole of NH4 4OH and X mole of H plus. This is in terms of concentration, so we can write X square divided by 0.05 minus X. This is equals to hydrolysis constant, that is Kw by Kb. Kw is 10 to the power minus 14, and Kb is given for this acid, that is 1.8 into 10 to the power minus 5. So we will have X square divided by 0.05 minus X. This is 10 to the power minus 9 divided by 1.8. Now we will make an approximation here, and what is the approximation? That is 0.05 minus X is approximately equals to 0.05. The physical meaning of this assumption is that dissociation of NH4 plus is very low. That is hydrolysis extent is very low. So if I use this assumption, then I can write X square divided by 0.05. This is 10 to the power minus 9 divided by 1.8. Or we can have X square is equals to 0.05 into 10 to the power minus 9 divided by 1.8. Or I can write 50. This is 10 to the power minus 12 divided by 1.8. So X is equals to root over 50 by 1.8, and this is 10 to the power minus 6. So let us take root of 50 by 1.8. So square root of 50 divided by 1.8. So this is 5.27. So we'll have 5.27 into 10 to the power minus 6, and X is nothing but concentration of H plus. So concentration of H plus I know, that is 5.27 into 10 to the power minus 6. Once I know concentration, we can calculate pH, that is minus log of H plus. So minus log of 5.27 into 10 to the power minus 6. So let us take log 5.27 into 10 raised to the power minus 6. This is 5.27. So log is also 5.27, minus minus plus. So pH of this solution is 5.27. This is the pH at equivalence point. So at equivalence point, pH is 5.27, and that is basically less than 7. So it is a acidic region. And why we have acidic? This is because of hydrolysis of weak base, that is NH4 plus. Here we have hydrolysis of weak base. So why we have acidic? Acidic because hydrolysis of weak base salt. that is in this case NH4 plus. So whenever we have weak acid plus a strong base titration, or we have weak base plus a strong acid titration, pH at equivalence point is not 7. So in these cases pH at equivalence point is not equals to 7, but we have a titration of a strong acid plus a strong base. We will have pH at equivalence point that is exactly equals to 7. pH at equivalence point that is equals to 7, and this is because in these cases, let us say strong acid is HCl and a strong base is NaOH. In this case salt form is Na plus Cl minus. Neither Na plus hydrolyzes the water nor Cl minus hydrolyzes the water. So in case of a strong acid, a strong base, no hydrolysis occurs. No hydrolysis. So pH remains 7.